going to take a look at cubing binomials. So we have x plus 1 cubed equals x plus 1 times x plus 1 squared. So it's just expanding it here and here. So this x plus 1 squared, we could use the pattern, but let me do that the long way. So let me multiply x plus 1 here, x plus 1 times x plus 1, just so we can get that. So first, this is x squared plus x plus another x plus 1. So to simplify, that becomes x squared plus 2x plus 1. Now we're supposed to multiply these together. X plus 1 times x squared plus 2x plus 1. Let's do that with the box method. So this is x cubed, 2x squared, 1x, x squared, 2x, 1x, I'm sorry, it's 2x, and then 1 times 1 is 1. So now we can combine like terms here, or we can rewrite everything here. So x cubed plus 2x squared plus 1x squared plus 2x plus 1x plus 1. So then we're going to write it in standard form, so combining like terms. We have x cubed, then we have 2x squared plus 1x squared, that is 3x squared, 2x plus 1x, that is 3x, and the last one is just plus 1. I'm going to write 1 in the front of there. Now if we're going to multiply this, a plus b times a plus b squared, so I'm going to use the pattern. So this would be a squared plus 2 times ab plus b squared. Then we would multiply all of this together, again using the box method or whatever method you are most comfortable with. So if I do box method real quick, just remembering. So this is the long way to do it. So we're going to learn the shortcut, or if you remember from last lesson, we did do the shortcut of cubing a binomial with the pattern. But again, if you can't use the pattern, it's really hard, you can always multiply out the long way with the box method, and that's okay for now. So this is a cubed times 2a squared b times ab squared times b, 2ab squared, and b cubed. And then I'm just going to combine like terms here as they are. So those two go together, and then this also goes together here. So you would get a cubed plus 3a squared b plus 3ab squared plus b cubed. And again, I'm going to write the coefficients in the front. Now just to kind of shorten this, now you could keep on multiplying everything through, well, go ahead and pause the video. I'll have the answers here if you want to try to multiply these all out to see if you can get the rest of the patterns. So this is what you should have gotten if you multiplied it all the way through. So one thing that I really want you to notice is the coefficients of all of these terms that we have, all of these polynomials. So notice that the first number is always 1. Then the next one is 3. Now although it changes signs, it's still a 3. And then the next number is 3. And the last number is a 1. So there is a pattern to this. So a large part of just seeing that pattern, that actually applies to what's called the Pascal's triangle here. So this is Pascal's triangle, and looking at the numbers, we always have 1 in the front of all of the rows and also at the back. So it's always the first and the last. Another thing to notice is that the numbers below, so for example this 2, that is 1 plus 1, which is 2. This 3, from the 1 plus 2 is 3, 2 plus 1 is 3, and then 1 plus 3 is 4 to the row below it, 3 plus 3 is 6 below, and 3 plus 1 is 4. So that's how you get the next number. So we can figure out what this next row is just by knowing that really neat pattern. So we know the first number is 1. So if we were to add, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is also 10, 4 plus 1 is 5, and this last number is 1, and we could keep on going. So notice when we were cubing, we were actually in this box here. This box here. Now that looks like the fourth row, but when we take a look at this a little bit later, that is actually called our third row. So the first row is row 0, row 1, row 2, row 3, row 4, and here is row 5. So the coefficients of the binomial squared, or binomial cubed, match the coefficients of the third row of Pascal's triangle. Okay, so that's just the main thing that I want you to get. There's very patterned, so that's really beautiful about math.